Thank you all for coming. I'm very pleased to be back in Korea with the opportunity to present you with the latest and greatest news on how FIDO Alliance and our members are working together around the world to reduce our dependencies on passwords while improving the user experience, thus benefiting commerce as well as security. First, a reminder of why we have the FIDO Alliance. The members who formed this organization back in 2012 and have joined the organization since believe that the world has a password problem. To understand that problem, let's measure the problem. First, over 80% of all data breaches studied in this highly cited Verizon Data Breach Report were caused by the compromise of password credentials. Often, those passwords get compromised by a simple phishing attack where the attacker tricks the user into giving their secret, their password, to the attacker when they think they're giving it to the correct application. This is a very important vulnerability that we knew we had to engineer around. And even though 2016 was a record-breaking year for data breaches reported by the Identity Theft Resource Center, 2017 had an increase of over 45% in data breaches. So this is a bad problem, this is an expensive problem, and it's getting worse. Now, outside of security, passwords have other problems, even in the absence of attack. Over $1 million per year is the estimated cost for organizations through analysis from the industry analyst firm Forrester, because 20 to 50% of help desk calls are to reset passwords. And Visa did a study to find out why a large set of users studied why they did not finish their checkout process. This is very important. Transaction conversion rate. 49% of them said they did not complete the checkout because they were prompted for a password. So we have to remove this from the system. FIDO Alliance is the global industry collaboration dedicated to solving this problem, and the key for security is no dependency on shared secrets. And the key for usability is single gesture authentication. We're very proud of the members who are a part of the FIDO Alliance, especially our leadership, the companies that have joined the board of directors. Here are all of those companies that provide the strategic direction, both the technical leadership, so that we have best-of-breed technology that we produce, and the business leadership, so that the solutions we develop actually solve today's authentication problems. I'm very pleased to recognize Samsung, BC Card, and Rayon Secure as companies headquartered in Korea that sit on the FIDO Alliance Board of Directors. So, again, FIDO Alliance and FIDO authentication that we produce improves security over passwords or passwords plus one-time passcodes because we use public key cryptography for the underlying security. We develop open standards so that every product, every consumer electronics device, every website, every application can use this technology. We design the technology to work with a single gesture. Touch a fingerprint sensor, look at a camera, maybe speak, or even touch a button on a security key. Very simple user experience. And the result is phishing-resistant, true multi-factor authentication that's easy to use. So let's look at old authentication for a moment to appreciate how FIDO is different. Here we have the application server on the right, communicating over the internet to the user who has a device like a smartphone, PC, or tablet. First of all, passwords can be stolen from the server. When there is a data breach, the goal of the data breach is often to steal a data set, a database full of credentials that they can then reuse to attack other services. That's why we have exponential growth in data breaches and lost data records. Passwords can be entered into the fraudulent application. All you have to do is trick the user if your authentication scheme is dependent on shared secrets like passwords. And there's usability challenges with passwords. They're hard to remember and manage. They're inconvenient to type, especially on our smaller and smaller devices. Let's compare that to how FIDO authentication works and how we address each of those challenges. First, there are no secrets stored on the server. As you can see in the diagram, a user registers their credential with the application by having their device create a public-private key pair. They simply are asked by the application, would you like to register maybe your face authenticator, your fingerprint sensor, your security key? This is an invitation that comes from the application. They say yes. They give evidence of they're the right user, such as touching a fingerprint sensor. That's the user verification step. The device creates a public-private key pair, which is the new authentication credential for that account, and it's unique to that account at that service. The public key is shared with the application and stored in their database, so that later, when the application has to challenge the user, they send a FIDO-compliant challenge to the device. They turn the process over to the authenticator on the device. Let's say it's a fingerprint sensor that challenges the user to put their fingerprint on the sensor. If that passes, then the authenticator will sign the challenge using the correct private key, and that signed challenge is returned to the server. And they are authenticated because the server has the correct and unique public key that can verify the signature on the challenge. And that is why there is no secrets on the server. So if there is a data breach, the only thing the attacker gets are public keys. They cannot use these public keys to attack any other service. This is different from the password problem. The authenticator cannot be tricked by a social engineering attack. So whereas an attacker might use a domain that's very close in the spelling to a trusted website, and that might fool a user, that will not fool the FIDO authenticator because it only signs challenges that come from the same web origin or domain name. There's nothing to remember for the user. It relieves the burden of password management from the user. And there's no added friction to the transaction. It's a single touch or look system, which is better convenience and will result, as we know from studies, this does result in improved transaction volume for e-commerce. So to report on the standards that we have published to date, in 2014 we published our very first standards. They were UAF, Universal Authentication Framework, for a passwordless experience that combined FIDO public key cryptography with on-device user verification, such as passwords, and U2F, Universal Second Factor, which really replaced one-time passcodes with an easier-to-use, unphishable, stronger authenticator that would work after providing a traditional username and password. And in 2018, we published FIDO 2, new versions of FIDO authentication specifications that support all these use cases and specifically optimized to be implemented by operating systems and web browsers. That removes the distribution challenges that were associated with earlier versions of the technology. So who is using FIDO today? Sounds like a good design, good system, but it's only as good as it is used and as proves to be efficient at solving the password problem. So here are just a few examples of many, many very popular services from around the world that are already using FIDO authentication. You see some of the biggest names in technology and service, whether it's U2F, UAF, or the new FIDO 2. We have validation that the technology has been implemented correctly, deployed at scale, and interoperates in the real world. These deployments are supported by a certification program that tests FIDO servers and FIDO authenticators, proving that an implementation has built their product in conformance to our specifications, that they interoperate when tested against randomly selected products. And we recently introduced security certification so that we can test how well an authenticator protects the private key. We recently introduced biometric component certification, which tests the effectiveness of the biometric sensor. And we offer the Universal Server Badge for solutions that have proven to interoperate with all previously certified FIDO authenticators, regardless of specification version. Over 500 products certified since 2015. So now, what's new? As you already know, FIDO has been recognized as an international standard by the ITU, the International Telecommunications Union. The significance of this is both in the government sector, who often looks for international recognition before making a major investment in a new technology. Also, regulation. Some markets are regulated around how they authenticate their users, and this will add credibility to FIDO authentication as a first-tier solution in regulated markets. And it should clarify once and for all that FIDO is a true international effort, and in fact it is the international effort designed to solve the password problem. Also new this year is recognition by the W3C, moving FIDO authentication, which is referred to as web authentication specification in the W3C, part of the FIDO 2 specification set, allowing products to implement after this milestone is achieved, which has resulted in production today, support from Microsoft's Edge browser, Google's Chrome browser, Mozilla's Firefox browser. This enables websites to do what only native apps used to be able to do, which is to add FIDO authentication from an embedded authenticator as well as an external authenticator, cross-platform with any choice of browser. In addition to the web browser support, Google's Android operating system now has FIDO 2 API for both native applications and web browsers that run on Android. And Microsoft's Windows 10 authentication system, known as Windows Hello, is now also FIDO 2 compliant. This means all Windows 10 devices have FIDO 2 authenticators. And this means all Android devices running Android from the last 2 or 3 years with a fingerprint sensor, they automatically have FIDO 2 authenticators. In addition, we earlier this morning had questions about Apple. So in addition to all of this, Apple is also visibly implementing FIDO 2 for their authentication system, as you can witness in the WebKit open source project, which is the underlying technology for Safari. So in summary, FIDO is designed to be secure. It's based on public key cryptography. Keys stay on the device and are never shared. This defeats any kind of social engineering attack to steal credentials. There are no secrets stored on the server. This defeats replay attacks if a server is breached. There's no third party in the protocol. FIDO is point-to-point. There's no dependency on a third-party service. Biometrics, if they are used, FIDO specifications require that the biometrics stay on the device. This is a privacy feature and a security feature. And there's no linkability between accounts. FIDO authenticators do not provide a unique identifier that would allow the user to be tracked across services. So all of this is privacy by design and security by design. And it's security in practice. This is a recent story published by one of the leading security publications in the US, documenting Google's experience, which they shared publicly, after 18 months of requiring all of their employees to use FIDO authentication, all 85,000 employees, not one case of successful phishing attack. Remember, phishing attacks worked 1 out of 14 times. But with FIDO, phishing attacks never work. And as you imagine, employees of a very visible company like Google are attacked quite often. So I'll leave you with these words shared by Vint Cerf, co-inventor of the Internet, on the occasion of the Internet's 49th birthday, which is recognized as Internet Day, earlier this year. If I could start over again, I would have introduced a lot more strong authentication and cryptography into the system. It is good to see new Internet standards from FIDO Alliance and W3C filling that gap. This is truly historic technology, enabling a fundamentally new, better, and more secure way to transact online. Thank you.